Hey there, this is Mr. Alexander, and today I'm going to talk to you about two things, writing inverses and finding compositions of functions, which is what we covered in class on August 31st and September 1st. So let's jump right into it. If I've got some discrete data like this here, and I want to find the inverse of that data, all I have to do is flip the x and the y's. When I say flip, I'm not talking about the sign. I'm talking about exchanging the x's and y's. So the inverse is simply 7 comma negative 5, because I flipped them, exchanged the x and the y's, negative 8 comma negative 6, negative 2 comma 1, and then 3, 10. Just flip them all. That's all you need for discrete data. But if you have something continuous data like a function, we're still going to flip all the x's and y's, but we have an algebraic way of doing that. So let's talk about this first function here. F of x equals 12x minus 3. The first thing you want to do is exchange f of x for y. F of x and y are synonymous, but it's easier if we get this out of function notation. So I'm going to make it y equals 12x minus 3. And again, f of x and y, they're the exact same thing, so you can interchange them as much as you'd like. After you've done that, then we want to flip all the x's and y's just like we did for the discrete data. So to flip the x's and y's, I'm going to do x equals 12y minus 3. At this point, you're going to want to just solve for y, get the y by itself. So we're going to add 3 to both sides. We get x plus 3 equals 12y. And then we're going to want to divide both sides by 12 to get the y by itself. I'm going to go ahead and bring the y. I'm going to bring it over here to the front. I'm going to make that y equals x plus 3 over 12. And this process has one more step. It isn't an inverse until you tell me it's an inverse. So you take the y out and you write it in function notation. So the last step here is to make this f inverse of x equals x plus 3 divided by 12. That's the inverse. This little symbol here is just function notation, which tells me it's the inverse of the function. And this is the very last step. That's the last thing you need to do, is put it back into function notation. So I want to do that 2 more times so that you can see exactly how I do some of these. So here's a completely different function. F of x equals negative 3/4 x plus 5. So the first step, get rid of that f of x, put in a y. Y equals negative 3/4 x plus 5. And then exchange the x and the y. X equals negative 3/4 y, plus 5. So I exchanged the x and the y. That's a y. Sorry about the sloppiness. And now we're going to solve for y. We're going to get that y by itself. So let's subtract 5. Subtract 5. I'm going to have x minus 5 equals negative 3/4 y. Now, fractions are a thing that sometimes people get tripped up with. The easiest way to get rid of this negative 3/4 is to multiply by the reciprocal. So I'm going to multiply both sides by negative 4 over 3. It's still negative, because the negative and the negative makes a positive, so they cancel out. That 3 cancels with that 3, and that 4 cancels with that 4, and that negative cancels with that negative. So I'm left with just y, but I need to do it on the other side as well. And I need to multiply the entire other side by negative 4/3. So I've got y equals negative 4/3 parentheses x minus 5. Now you can keep it in this form. You don't have to distribute that negative 4/3 if you don't want to. You can leave it just like this, and that's fine. But there's one last step. You need to put it back into function notation. So f inverse of x equals negative 4 over 3 parentheses x minus 5. So if you distribute that negative 4/3, that's okay. You don't have to do that, but you can, and you'll have the right answer as well. Okay, so put a big circle around it because that's our inverse. I want to show you one more, and then we'll talk about compositions of functions. F of x equals, in parentheses, x plus 3 squared. First step, get rid of that f of x, make it a y. Y equals x plus 3 squared. Then exchange the x and the y. X equals y plus 3 squared. Okay, so now this whole thing is squared. Some of you might be tempted to subtract the 3 first, but that would be bad. You don't want to do that. You want to get rid of the squared first. We're working from the outside in. And the opposite of a square is a square root. So I'm going to take the square root of both sides. But remember that whenever you take a square root, you're not just taking one square root. You're going to end up with the positive and negative of that square root. Like the square root of 4 is not just 2. Square root of 4 is positive and negative 2. So this is a positive and negative in front there. I don't need to do it over here because that square root and that square, they're going to cancel each other out. They're going to disappear, so I don't need to bother with the positive and negative. But I do need to keep it on the remaining square root. And over here I'm left with just y plus 3. At this point, I want to get the y by itself, so I'm going to go ahead and subtract 3 from both sides. So I've got, and I'm going to move the y over there, y equals positive and negative square root x minus 3. And the last step, of course, is to write it in function notation. F inverse of x equals positive and negative root x minus 3, and put a big box around it because that's your inverse. So that's it. That's inverses of functions. I want to talk about the other part of the lesson now. I want to talk about compositions of functions. So I'm going to put this paper to the side, and I want to do this right here now. Zoom out. So I've got two functions. I've got g of x. G of x equals negative x plus 3. And I have h of x, which is 4x. And I want to find g of h of 7. This is kind of a two-step process. The first step is to go ahead and plug h into g. So I don't want to do g of x anymore. I want to do g of whatever h of x is. In this case, it's 4x. So I'm plugging 4x into that g function. So I'm going to write down all of g, which is negative. Where I get to the x, I want you to just put some parentheses there. Forget about the x for a minute. Plus 3. So g of x is negative x plus 3. But I left out the x because where the x was, I'm going to put in 4x. That's what I'm plugging into this equation here. And so I can simplify this a little bit and make this negative 4x plus 3. That's g of h of x. Now notice my notation here. I didn't use the same thing over here. These two are interchangeable. So that g of h is the same as this g of h of x. It's the same thing. So if I want to find g of h of 7, that means I'm going to plug 7 into this equation right here, my g of h of x equation. So I'm going to do g of h of 7 instead of x. So it's going to be negative 4 times 7 plus 3. Of course, when you work all that out, negative 4 times 7 is negative 28. Negative 28 plus 3 is negative 25. So that's that first one there. Let's do one that's slightly more complicated. H of g, and h of t is 4t minus 5, and g of t is t to the third minus 3t. And I want to find h of g. So the way I'm going to do that is I'm going to take my h function. I'm just going to copy it down. And where the t is, I'm going to leave some parentheses. So I've got my h without the t in there. And where the t was, I'm going to put g of t, which is t to the third minus 3t. And I'm going to put it in both spots. And I can simplify that by distributing the 4. So I can make that 4t to the third minus 12t, because 4 times 3 is 12, minus 5. That's my h of g of t function. So now I can take that function and plug the 3 in there to get h of g of 3. So I'm going to do 4 times 3 cubed minus 12 times 3 minus 5. 3 cubed is 3 times 3 times 3, that's 27. And 27 times 4 is 108. 12 times 3 is 36, and we're going to subtract 5 from all that. So 108 minus 36 minus 5 is 67. All right, last one. Two functions. F of n is n squared minus 5, and g of n is n minus 5, and I'm trying to find f of g of 7. So I'm going to copy down the f function, and where the n was, I'm going to put some parentheses. So something squared minus 5. And where that n was, I'm going to put g. So I'm going to put n minus 5. n minus 5. And believe it or not, there's not much we need to do here. This is fully simplified. You could go ahead and FOIL this out if you want to, but I think it makes it unnecessarily complicated. So I'm going to go ahead and say f of g of x equals n minus 5 squared minus 5. Just like that. That's okay. Because from here it's really easy to plug in the 7, which is what we're going to do next. We're going to find f of g of 7, which equals 7 minus 5 squared minus 5. 7 minus 5 is just 2. 2 squared is 4. 4 minus 5 is negative 1. All right, that's it. That was finding inverses and compositions of functions. Thank you for watching. Hope it was useful. See you in class.